Hello everyone, my name is Vamsi Ramayanam. Welcome to my Capstone project presentation titled AI-powered diabetes and retinopathy detection. So this application predicts diabetes risk using health data and retinopathy severity using retinal images. So it delivers real-time results through a user-friendly web interface, leveraging machine learning to support early and proactive healthcare interventions. So globally, over 400 million individuals are living with diabetes, with the risk of serious complications if undetected. Early diagnosis dramatically improves outcomes, reducing long term damage such as vision loss. So, this project is personally and professionally meaningful to me, driven by experiences witnessing the impact of late diagnosis. My goal was to empower users with accessible AI driven tools for better health decisions. So, for diabetes prediction, I used the PIMA Indian diabetes dataset from Kaggle, which is a widely used benchmark for health based machine learning. For retinopathy detection, I used a retinal image dataset categorized by disease severity. So data processing included replacing missing values or unrealistic values, such as glucose values is equal to zeros or any other outliers with some median values or missing values with the median values, and categorizing BMI, age, and glucose levels into clinically meaningful ranges. SMORT was applied to handle class imbalances, ensuring that the models could generalize better across minority risk categories. I built two separate pipelines. For diabetes predictions, I trained random forest and XGBoost models, later combining them using a voting classifier to improve prediction robustness. And for retinal image analysis, I developed a convolutional neural network with the three convolutional layers, which are dropout, regularization, and dense layers. To enhance CNN performance on a limited dataset, I used data augmentation techniques such as flipping, rotation, and scaling. So finally, the trained models were saved as .pkl and .h5 files for easy integration with the web application. So the web application was developed using a Flask-based and responsive front-end built with HTML, CSS, and JavaScript. Machine learning models are integrated directly into the Flask routes, enabling real-time predictions. User data and prediction results are stored securely using SQLite and SQL Alchemy ORM. Security is a critical focus. The application uses a Flask login for user authentication with password encrypted using a bcrypt hashing. Session timeout is enforced after 3 minutes of inactivity to protect unattended sessions. And role-based access control ensures patients and healthcare providers have appropriate feature access. So when the user first time registers, he has to select the role, either he is a patient or a healthcare provider. Depending on the role that he chooses while registering, uh, the respective options will be uh, available for the users. All user predictions and inputs are stored securely in an SQLite database. Patients can view their historical data and monitor changes over time through trend visualizations. Dynamic line charts and pie charts help user interpret their health risks at a glance. The application is deployed using Azure Web Service, which hosts a Flask backend and enables global access via the cloud. The large um, trained models and the datasets have hosted using Azure Blob Storage for scalability and quick retrieval. I have implemented Azure DevOps pipeline for automated deployment and continuous integrations. Uh, this fast cloud approach ensures high availability and faster updates and access from anywhere with an internet connections. So I've used web app services for hosting this Flask application. And I have a plan to implement a few features in future. Obviously, I want to, right now it is a web-based application. I want to uh, develop, I want to probably extend this to a mobile version of the application for a broader accessibility. And I aim to enhance the result interpretation, which offers user recommendation alongside risk scores. This particular feature, which I'm still working on it, this is not there in the initial requirement, but I am still working on it. Definitely, I would continue to work on these enhancements as I continue this journey. Right now, I'm still working on it. This feature I have enabled in the final application though, but it doesn't offer any feature functionality as such. Users will have the option to select the healthcare provider for follow based on their results. In case of high risk prediction, the system will send automated healthcare alerts promoting users to seek immediate medical attention. So these are additional features that I have a plan to implement. And obviously, right now my application supports the prediction only the diabetes, but in future I want to integrate this with multiple other chronic diseases. These are my future enhancements. So now let's get back to the demo part of it. So this is the user interface, and user first will after first time user has to click on this register button. He will select either username, enter email ID, and choose his passwords. And then they will have to select the role, whether there's a patient or a healthcare provider. Since I have already registered, I will log in with the role patient. So first time, this is the welcome dashboard. Here it will show the summary of user mini health details, where user will see his recently entered values and predictions. Now he can enter values like zeros, like 120, 90, 35, probably 120, BMI 38, 0.8, age is 30. Let's say user will have to enter these values and click on this prediction button. This prediction will show you these are the details that I have entered, and these numbers indicate that there is a high risk of being um, a diabetic for this one. So these are the results that it shows, and these are my historical information that the system has saved for me to come back and then look into it. So prediction engine is something there where I can come anytime and then see my historical predictions. Similarly, I have an option to upload a retinopathy image. I will choose here, probably I'll select any image. These are my retinal images. Click on upload the button and click on predict. Upon prediction, it shows me this is not a no, I'm not a diabetic with this image that it predicts, and then shows the confidence level as well. And user has an option to navigate to the data visualizations tab. Here you can see based on the prediction values that the user has entered, it saves all those details and then can be used as a visualization. It shows the various graphs. Uh, Here the graphs include the glucose level over time, prediction results over time. Uh, Here it indicates high, moderate, and low, and blood pressure over time, and BMI over time, risk level distribution based on all my predictions. This shows the distribution of my risks. This is a clear and easily user can interpret how this blood pressures and glucose levels are uh, varying at different times. This is what I have talked about. The result interpretation is still in progress. It is not a initial requirement. This is an enhancement. And user has an option to enter the feedback. Either you can enter your name optionally and your email ID, and select the ratings of this app or the doctor that you are working with, and then you can leave your comment here. If you come back to this one thing, if you have noticed this, all these uh, results are for the same particular user only. It is not showing the different other users information. Similarly, if I log out and then log in as a doctor or a healthcare provider, this is a different user. This time, instead of patient, I choose a healthcare provider. Login. Here, if I see, since this profile is a healthcare provider, he has an option to filter the different patients. And also he can see, you see this username where he has an option to see all the different patients um, that the end users are using this app to enter their predictions. Now, if I want to filter on one particular patient, I can filter, it restricts all the data for this particular patient. Similarly, if I want to see the patient JAG details, I will enter here, and then all these predictions I will show as a this guy has prediction confidence as 82 with a low risk of diabetes. These are all his historical information. That way, these healthcare providers will have access to the multiple patients' data. But whereas if you log in with a patient profile, you should be able to see only your data, and that all the passwords and the other patients' data are strictly uh, secured here. Let's go back to the presentation. And before I present this, let me show you my app structure. Um, yeah, these are the different versions that I've created as part of my development and testing. And this is my project folder where I have all these files. Um, all this database related details are here. And my template has all the HTML files, which are again added as a different routes in the app.py file. And I have uh, all the different categorized retinal images saved in these different folders. For example, if you look at it here, I have this category 0 to 4 different categories of sample data sets are here. And this is my app.py, and these are all the different uh, Python files that I have. For your review, I have uploaded this in the GitHub so that you can access these files. And yeah, so this is the live version of the app URL that you can log in. Instructions are given in the GitHub, but however, I will reiterate it. First, you have to register as a user or a healthcare provider. Then you can enter your details. um, I will also upload some of the images in this Git repository, where you can go to this train sample data folder, where you can access these images for your testing. These are all few images that I've used for your access, but otherwise I have, if I just go back here, I have lots of images for different categories. These are all the tech stacks that I've used for developing this project. Thank you very much.